Look at this flock. Hundreds of birds turning together. Like one giant animal made of many small ones. Here is the surprise. There is no leader. No bird is in charge. Nobody has a map or a plan. Each bird follows a few tiny rules. And intelligence appears from the group. Scientists call this emergence. This lecture asks one question. Can teams of AI language models work the same way? Let's find out. In 1986, Craig Reynolds recreated flocking on a computer with just 3 rules. Watch them one at a time. Rule 1, separation. Don't crowd your neighbors. Everyone keeps a little personal space. Rule 2, alignment. Fly in roughly the same direction as the birds near you. Rule 3, cohesion. Drift toward the middle of your neighbors, so the group stays together. All 3 together, and a flock is born. Simple local rules, no boss, smart group behavior. Nature invented many swarm tricks. And computer scientists copied them as algorithms, a whole zoo of them. Ant colony, particle swarm, bee colony, gray wolf, firefly, cuckoo. The names sound like a safari. The secret, they are really just 5 big ideas. Here they are, the 5 primitives. Learn these 5, and you understand the whole zoo. Next, let's meet the 2 most famous members in action. Ants find the shortest way to food with no map and no boss. Their trick, they leave a chemical trail. Pheromone. 2 paths. One short, one long. Ants on the short path finish trips sooner. So their trail gets refreshed faster. A stronger trail attracts more ants. Which makes it stronger still. A feedback loop quietly elects the best path. And the trail evaporates. If the world changes, old answers fade, the colony can change its mind. Coordinating by notes left in a shared place has a lovely name. Stigmergy. Remember it. We'll reuse it for AI. Now birds. As a search party, these particles are hunting for the highest point in a hidden landscape. Pull number 1, momentum. Each particle mostly keeps flying the way it was already going. Pull number 2, personal best. It remembers the best spot it ever found, and is drawn back toward it. Pull number 3, global best. It's also drawn to the best spot anyone in the swarm has found. Blend the 3 pulls and the swarm sniffs out the peak together. That's particle swarm optimization. Now the big question. Can we use these tricks with AI language agents? Almost. 3 things change. First, a particle's position is a number. An agent's position is an idea. A draft. A plan. A piece of code. Second, a particle moves with cheap arithmetic. An agent moves by rewriting its idea. An expensive LLM call. Third, fitness isn't a formula. It's a judge. Usually another model scoring the work. Noisy. And not free. So we don't copy nature's equations. We copy nature's ideas. The 5 primitives. Into the world of language. Here's the payoff. The 3 flocking rules map perfectly onto a team of AI agents discussing a problem. Separation becomes, don't repeat what others said, bring something new. That is diversity. Alignment becomes, move toward what the group is agreeing on. That is consensus. Cohesion becomes, stay on the task. It keeps the whole conversation from wandering off. Tune the 3 knobs and you choose the meeting. All separation equals wild brainstorm, all alignment equals groupthink, balanced equals real deliberation. Zoom out, and every swarm trick hides one master dial. We call it convergence, pressure, pi. Turn pi toward converge. Everyone is pulled to a single champion answer. The swarm collapses to 1 point. Turn pi toward diversify. Agents spread out. Each becomes the best of its own neighborhood. One answer. Or a map of many good answers? Same machinery, opposite goals. This is the real design decision. When you want many good answers, borrow a trick called map elites. Divide the space of ideas into cells. Each cell keeps only its best solution so far, its local champion, the elite. Agents now flock to the champion of their own cell, not one global winner. Watch the map light up. We call this an illuminated swarm. Instead of one answer, you get a whole gallery of strong, different answers. One more secret. Let's slowly turn up how much agents listen to each other, the coupling kappa. For a while, nothing. Everyone does their own thing. Then suddenly, snap, the whole swarm locks into agreement. That sudden snap is a phase transition. Like water freezing into ice. Order appears almost all at once. The best thinking happens right at the edge, connected enough to share, free enough to disagree. Bonus. A simple thermostat can hold the swarm at that edge automatically. Measure diversity. Nudge the dial. Repeat. Let's zoom out. Everything we learned becomes 7 Lego blocks you can snap together. Deposit trails pull uphill flock with 3 forces rank leaders leap big or small. Illuminate the map, regulate the dial. Snap them in different orders and you build different machines. A pathfinder, a brainstormer, a refiner. The whole lecture in one sentence. Don't copy nature's equations, compose nature's ideas. What is stigmergy? Right. Ants never talk directly. They coordinate through pheromone trails left in the environment. For AI agents, the trail is a shared memory of good idea fragments that slowly fades. In a swarm of LLM agents, what plays the role of fitness? Exactly. There is no clean F. X. For ideas. Quality is a judgment. Usually from a critic, verifier model. That makes fitness noisy and costly, which changes the whole design. What happens at the edge of consensus? Yes, peak collective thinking sits at the phase transition. Correlated but not collapsed. Full agreement is groupthink. Zero coupling is chaos. Tune to the edge. Checkpoint complete. You've got the core ideas. Let's wrap up. You now know the 5 primitives. The master dial pi. The illuminated swarm. And the edge of consensus. Next time you see birds turn as one. Remember, no leader, simple rules, shared signals. That's the future of AI teams too. This was a NeuraForge lecture. The full research note goes much deeper. See you there, honeybee.